Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on Euler, Weber and Mach model law. So actually, this concept we have discussed in the previous lecture, the theory and derivation part of this Euler model law, Mach model and Weber model law. So based on that concept, we'll solve a problem here. So the question is given, the pressure drop in an aeroplane model size of 1 by 40 of its prototype is given 80 Newton per centimeter square. The model is tested in water and we need to find out the corresponding pressure drop in the prototype, and density of air is given 1.24 kg per meter cube. Viscosity of water is given 0.01 poise, while viscosity of air is given 0.00018 poise. So these are the data given and we need to find out the pressure drop for the prototype. So the question is very simple. So let's write down what are the data given first. So I'll write here, this is, you can write the data given, and first line itself we can see the length ratio is given 1 by 40, the model size is given, that is 1 by 40, so we can write that is scale ratio. So that is scale ratio, either length ratio or we can say linear scale ratio, that is. So it need to be mentioned LR, so this is 40. And similarly the pressure drop is given, let mention it, this is PM only. So PM equal to is given 80 Newton per centimeter square. Let convert this one into in terms of meter square. So that is 80 into 10 to the power 4 Newton per meter square. So similarly the density of air is given. So density of air, let density of air write down, this is 1.24 kg per meter cube. And similarly density of water we know, this is, we can consider that is 1000, so 1000 kg per meter cube. And yeah, viscosity of what water is given, viscosity of water, so this is viscosity of water, this is 0.01 poise, 0.01 poise. And viscosity of air, viscosity of air is given, this is 0.00018 poise. Okay, and yeah, these are the data only given. So density of air also, it is given 1.24. So all the data I have written here. Now we need to find out the pressure drop for the prototype. Actually, if you see pressure drop here, I write here. So what we need to calculate here, let me write, P of P need to be calculated. Okay, now as you can see, this problem is involved with viscous force. This problem is involved with viscous force. Then we need to see which model is related to viscous. And if you see, the viscous related is nothing but that is a Reynolds number, because we know the Reynolds number equal to inertia force by viscous force. So Reynolds number need to be considered here. That is one point. We need to take the Reynolds number. And also we need to see pressure force also involved here, because pressure is given here. So pressure force involved means where, in which number the pressure force is related. So actually if you remember, in Euler's number, Euler number equal to inertia force by pressure force square root. So this is the two number we need to consider. We need to equalize. That means Reynolds number for the prototype equal to Reynolds number for the model. Similarly, Euler number for the prototype equal to Euler number to of the prototype. That need to be considered. So first we'll see this Reynolds number. Let's write down the Reynolds number of the prototype and Reynolds number for the model. So if I write, so I can say this is, we know the Reynolds number equal to rho, V and D. But here we can consider this is length, because the length ratio is given. So this is rho VL by mu, rho VL by mu. So this is for the model, this is for the model, this is for the model, and this is for the model, equal to, similarly we can write rho VL, this is for the prototype, divided by, this is Reynolds number for the model, this is Reynolds number for the prototype. Now from this again we can write, this is Vm, and let's take this Vp to the downward here in the denominator. So you can write this equal to, remaining things we can write rho p by rho m, rho p by rho m. Then length also you can write LP by Ln, and here we can write this is mu p by mu m by mu p. So what are the data are given? Rho p by rho m given. So rho p rho p equal to nothing but this is, okay, 1.24, that is rho p. So this one we can write, this is rho p prototype, and rho m is nothing but water. Here you can write like that. Similarly, this also you can write, this is mu m, because in the model we are using this water is there, and for the prototype air. And similarly, this is mu p. Just you put this value in this all this equation, if you see, then we can get LP by suppose Lm. Let's consider LP by Lm. Okay, so that is nothing but LR, we know that length ratio. So this is given 40. LP by Lm equal to LR, and that one we can write this is 40. So this value is, we got it. Now similarly we can write this is rho p by rho m. How much is the rho p is given? This is 1.24 divided by this is 1000. Okay, similarly mu m by mu p, this is actually 0.01, this one water, and this is 0.00018. Okay, now if you solve, we can get the value of Vm by Vp. Now put all this value in this equation so that we can find out Vm by Vp equal to what we can write, 1.24 divided by 1000 into this is 40 length ratio into 0.01 divided by 0.00018. So if we solve this, we will get the value of this one. Okay, so let's see how much we are getting. So 1.24 divided by 1000 equal to into 40 into 0.01 and divided by 0.00018. So we'll get the value of 2.755. So the same thing we can write, this is 2.755. So this is the ratio. This is not the ratio. Ratio equal to, actually we can write Vp by Vm equal to, we can write that is velocity ratio, but it is given, we got here Vm by Vp. Okay, we'll use this value in the next steps. So now, as I told you, one thing is completed, that is Reynolds number. Now another force is related here, that is pressure force. So the pressure force is nothing but it will come under the Euler's law. Now this Euler's number should be equal for the both. So what we can write, Euler's number we got there actually. This one is Vm divided by this square root of what? Pm divided by rho m. Similarly, this one also you can write Vp divided by V subscript P, and this is root over of, this is Pp divided by rho P. The Euler's number of this model, Euler number for the prototype. Now again, this equation can be written, let me write in this way, Vm divided by Vp equal to, just take this value in the numerator, this is Pm divided by rho m, and similarly root over of Pp divided by rho p. Again this one we can write, let me write here, this one we can write, this is Vm by Vp. Why I am keeping this Vm by Vp? Because I already got the value here. That's why I am not making it Vp by Vm. So again you can write, this is root over of Pm. You can write this is Pm by Pp and into root over of rho p by rho m. This equation I have just separated in this way. Okay, now we got this value of this, so we can write, and here if you see, we got the, we have the value of rho p and rho m. So this value is given, so you can find out this one. So now put this value, this is how much, 2.755. 0.755 equal to root over of Pm by Pp into, this is root over of 1.25 divided by 1000, and this value we can solve it actually. So let's find out. This is 1.24 divided by 1000 and root over of this, so 0.035, 0.0352. So you can write this one here. Let put this value, root over of Pm divided by root over of Pp into 0. This is 0.352. We got this value, correct? Now we'll keep this term here, root over of, this is Pm divided by Pp, and this one equal to 2.755 divided by 0.0352. Okay, now let's see how much we are getting. So we can find out. Now 2.755 divided by 0.0352. So 78.27 will write. 78. This is 28, suppose I'm writing. Okay, this is the value of this. Now again, we just can write in this way, Pm divided by Pp. So that is, we'll write this is root over of 78.28. Sorry, root over not. We can write this is square, because square root removed here means we can make it square here. So that means this is whole square of this 78.28 whole square. So we can write this again. Let make it square. So we'll get something of this 6125. Okay, 6125. Let write another in way. Keep it there. So now I'll write this Pm by Pp. So one value is given, Pm is given. So Pm is given how much? 80. So what I'll do here, Pm divided by this 78.28 square equal to Pp, and finally we'll get the value of Pp equal to 80 into 10 to the power 4 divided by this 78 square. So finally we'll get the value of Pp equal to, let me solve it, then we'll see here how much. So if you see this one already I got 6125. So let me write here. Suppose this is 6125. So here this Newton per meter square, and this is yeah. So let's see, 80 into 10 to the power 4. So that means we will get, sorry, 80, 1, 2, 3, 4 divided by 6125 something we got, 6175, 124. No, not like that. So I'll do one thing. So if you want to calculate in terms of like centimeter square, we can keep like this, or else we can do that one to the power 4. So we'll get 8 lakhs divided by I'll do one thing, divided by bracket of 78.28 bracket close square. So that equal to 130 something 55 we are getting, correct? So this is we are getting in terms of Newton per meter square. Okay, so let me write, this is 130.55. This is Newton per meter square. Again, this one if you want to write in terms of centimeter square also you can write. This will divide by 10 to the power 4. So we'll get that one value 0.01306, that is Newton per centimeter square. So this is the final solution for this. I hope you understand this problem. If you are having doubt regarding this, you can give a comment on the comment box. Anyway, this problem is very simple. I hope you understood this. Thank you all.